So this theory part we have already covered in our last class, projectile from a cliff. Equations we have seen how to derive those. We have also done this question in our class.
Yes, sir. Yes, sir.
But this question was not solved, I think. The question says that two particles are projected, one from top, another from bottom of a tower. Right, so this is a tower. Now two particles are projected, one from top, suppose in this way, another from bottom, suppose in this way. It is u, it is v, right? Their angles are only given, that it is alpha and this is beta. Now they are colliding in mid-air, right? So if the second particle is moving like this, and if the first particle is moving like this, then in mid-air means they are colliding at this point, at this particular point, right? It says that the horizontal distance from this tower to this particular point is a. So if I draw this horizontal line, this horizontal distance is a, right? If I assume that the height of the tower is h, let us assume it to be capital H. I need to calculate the capital H. Now tell me, if I assume that after time t they collide, right? Again, let us assume after time t they collide. Now if after time t they collide, then can I understand that at a time t their horizontal displacements are the same?
Horizontal and vertical both will be same.
Vertical positions are same, horizontal positions are also same, because their x and y coordinate both should match with each other, then only they will collide. Yes or no?
Yes, sir.
Suppose this is my x-axis, this is my y-axis.
So can you please repeat once again, like why they will collide, like why the horizontal components will be equal?
If two particles collide, what does that mean? That their positions must coincide, then only they will collide.
Sir, I was saying something.
Yes or no?
Yes, sir.
If their positions does not coincide, how can they collide? That means their y position as well as x position has to be the same. X and y, both the coordinates have to be the same. So what is the x coordinate of both the particles? Can you tell me? A. Right? If A is the x coordinate, then what is the x position of the first particle?
Ut cos alpha. Ut cos alpha t. Cos alpha t.
Yes, it is ut cos alpha. And for the second particle, what is the x displacement?
Ut cos beta. Sir, are you saying something?
Yes. Tell me. So it is the first equation that I can draw, that both of them are having the same horizontal displacement. Now,
Sir, Vt cos beta.
Vt cos beta, yes. It should be Vt cos beta. Now, what about their vertical position? Can you tell me what is the vertical position of the first particle after time t? What equation I can write?
Sin alpha t minus
Sin alpha minus half t square.
Ut sin alpha minus
half gt
Half
square.
gt square. So plus h also.
Yes, plus h. Why? It is the displacement, and plus h as its initial position vector is plus h. You can see, as I have taken this my origin, so the initial position vector of the first particle to be plus h. What is initial position vector of the second particle?
T sin alpha t minus half gt square.
Its initial position vector is 0. So its
0.
position vector can be written as only Vt sin alpha minus half gt square.
The sin beta.
Sin beta. Okay,
Yes,
now
sir.
can you say that these two y coordinates also should match in order to collide.
Yes, sir.
Yes?
Sir,
Yes, tell me.
Yes, sir. Sir, if we take the frame of reference from that top of the
Yes.
clip,
Then in that case, your y2 should have a minus h and this will be 0.
okay, sir.
Right? In both the case, you will find the same equation after equating this to, can I say h is equal to vt sine beta minus ut sine alpha. Can I write this equation if I equate this to?
Yes, sir.
Now it is simple. I will just replace vt and ut from this equation number 1. So vt is a by cos beta. And what is ut? Ut is a by cos alpha. Right? So if you take a common, you will find it is tan beta minus tan alpha. That should be the answer of this question. Now let us try to solve this question. It is not a tough question. We have solved similar type of question earlier also. It is only the similar concept, but application is different. What the question is saying, that there is one tower. Suppose it is a tower, and from the top of the tower, now two particles are being projected. One is horizontally along horizontal direction with 10 meter per second, another at certain angle 53 degree, and its velocity is v. So if I project it with 10 meter per second, and let us assume that another particle is projected with v at angle 53 degree, so, and we will assume that after time t the balls actually collide. Let us assume that after a time t, they collide, right? They collide. So we will first they are not colliding. I think that after time t their velocities are becoming perpendicular, right? So after time t their velocities are perpendicular. Their velocities are perpendicular. I will first write down the velocity of this ball after time t v1, and after time t I will write down the velocity of the second ball as v2. So in a vector notation, what I should write as v1 vector, if I have taken the horizontal to be x and vertical to be y axis.
So 10 I cap minus 10 t j cap.
10 I cap minus 10 into t j cap.
T j cap.
Yes. Everyone should understand this thing. Why I have written that? Because its x component remains constant. So it is 10 I cap as it is, I have written it. And y component will be u minus at, u minus gt. But here initial y component is 0. So it is only minus gt. Can you tell me what is the velocity of the second ball after time t?
Sir, 3v by 5 I cap.
Yes. What is the x component of this v? It is 3v by 5. 3v by 5 I cap plus. Now its y
Plus
component will
4v.
follow the v equal to u plus at equation, right? So I will
Yes,
write 4v by 5
4v by 5 minus 10 t j cap.
minus 10 t j cap. So that is the velocity of the second ball, and it is the velocity of the first ball. Now as the question says that they are perpendicular to each other, then we understand that what we have to do, we have to find a dot product of these two vectors, and if they are perpendicular, what should be the value of the dot product? 0, right?
0.
So if you do a dot product, can you just tell me what we'll get after just doing a dot product?
30v by 5, that is 6v.
6v, and it will be
Minus 8vt by 5.
8vt and plus
100 t square.
100 t square. So that is equal to 0 according to this equation. And you can see that this is a quadratic expression for time. Again, if I slightly modify it by cancelling it with 2, we can say it is 50t square minus 4vt plus 3v is equal to 0. Now it is a quadratic equation expression for time. In order to find a real time solution of this expression, what should be the condition for this quadratic expression? Can anyone tell me?
Sir, discriminant must be greater than equals to 0.
Yes, good. If discriminant is greater than or equal to 0, then only we will get a real solution of the time. Otherwise, the solutions are not real, right? So, what is the discriminant? We will write discriminant greater than or equal to 0, and discriminant is b square, that is 16v square minus of 4ac, 4 into 3v into 50. That can be greater than or equal to 0. In that case, only we will find the limiting value of v, that v should be greater than or equal to, if you simplify it, you will find it is 75 by 2 or 37.5 meter per second. That should be the answer of this question, right? So from there you can say that v should be greater than 75 by 2, greater than or equal to 75 by 2, and in this case only they can be perpendicular to each other. And now in the second question, that it says that find the time after which the velocities will be perpendicular. If the value of v you will take 75 by 2. So if you take the value of v to be 75 by 2, its discriminant will be definitely 0, because I have found the value by making discriminant greater than or equal to 0. So if you take the exact value, you will find its discriminant to be 0. If discriminant is 0, then what is the solution of the quadratic equation? Can you tell me? If discriminant is 0,
the minus b plus minus root over d by 2a.
Now discriminant is 0, na? So what is the solution?
Minus b by
Yes,
2a.
minus b by 2a only. So here minus b is 4v, minus b is 4v, and divided by 2a is 100. Have you understood this part? I have
Yes,
only
sir.
put the value from here. This is b and this is a in my quadratic expression. So that is equal to, say 4v is equal to 150 by 100. So 1.5 seconds should be the answer of the second question. Have you tried this one?
So this one was not given.
This was not given.
This was not in the PDF.
Okay. I will give in today's PDF you will find this one. Okay, so you try this one also at your home. Bit calculation intensive question, but you can do that. All right. So today we will start in kinematics lecture number 6, projectile on inclined plane. As you can see in the diagram that I have projected a particle from the ground itself, but the particle does not land on the ground. The particle lands on an inclined plane. So how do I analyze this motion? There are two ways to analyze its journey. One is a very conventional way, that instead of taking horizontal and vertical line to be my xy axis, I have taken along the inclined plane to be my x-axis and vertical to the inclined plane to be my y-axis. Right? As I have to find the range along the inclined plane, that is why I have taken this coordinate axis. But as I have taken this to be my coordinate axis, I have to break all the vectors along the components along these two axes, x and y axis. Right? What are the vectors that I have to break? U vector and acceleration vector. Right? If I say that this angle is theta, which angle is theta? You need to understand that this entire angle is theta. U vector is projected.
That entire angle, or just that was given alpha also, sir?
This is angle theta, and this alpha is the angle of the inclination of the incline. What is theta? Theta is the angle of projection of the particle from ground. Right? So if I assume these two things, given in your diagram, if I try to write down the x and y components of all the vectors, can you tell me what is ux? What is initial velocity along x-axis?
U cos theta.
U cos theta minus
U
alpha.
cos theta minus
U cos
alpha.
theta minus alpha.
Theta minus alpha.
It is u cos theta minus alpha, because the angle between inclined plane and the angle of projection is theta minus alpha. And what is uy, the initial velocity along y-axis?
U sin
U sin theta minus
U
alpha.
sin theta minus alpha. Yes, good. Now, what is the acceleration along x and y axis? That also I have to find. In order to find the acceleration, you can see that actual acceleration of the particle is always along this line, yes or no? Actual acceleration is definitely vertical direction, right? And if I have to take the component of this acceleration along this two lines, so what I will take?
G cos alpha.
Which angle is if this is g vector, this is g vector. Can you identify this angle? Can you identify this angle?
Alpha.
Theta minus alpha.
It is
Alpha.
alpha only, right? So what is this this vector?
G cos alpha. G cos alpha.
And what is this one?
G sin
G sin
alpha.
alpha.
G sin alpha.
G sin alpha, right? So you can write what is the acceleration along x-axis. Now is it 0? No. What is the value
Minus
of
G
this?
sin
Minus
alpha.
G sin
Minus G
alpha.
sin alpha.
Minus g sin alpha. Good. And what is the acceleration along y-axis?
Minus G
G
cos
cos
alpha.
alpha.
Minus g cos alpha. Now can I write what is the velocity along x-axis after a time t?
So can you please explain what is minus G sin alpha?
Because I have taken this to be my positive axis. Na? Along this line, all the vectors I have taken positive. You can see. That is why I have written ux to be positive u cos theta minus alpha, because the component of u along this line is along this direction, positive x-axis. So positive x-axis I have taken positive, and positive y-axis I have taken positive. So all the opposite vectors has to be taken negative. Can you see that the component along the inclined plane of the gravitational acceleration acts along negative x-axis?
Yes, sir.
That is why I have taken a negative sign before that. Similarly, the component of g along y-axis is along negative y-axis actually. So that is why I have taken a minus g cos alpha. Can you find me an expression for Vx and Vy?
Yes, sir.
So Vx is U cos theta minus alpha minus GT sin alpha.
Good. So Vx equal to U cos theta minus alpha minus GT sin alpha. And what is Vy?
U sin theta
U sin theta minus alpha
Minus
minus GT cos alpha.
GT cos alpha. Similarly, can I write down the displacement along x-axis after a time t? What will be the
So
displacement?
ut cos theta minus alpha
Ut cos theta minus
minus
alpha
half
minus
sin alpha t square.
minus half g sin alpha t square. And what is y-axis displacement after time t?
Ut sin theta minus alpha minus half GT square cos alpha.
Minus half gt square cos alpha. Right? Look, this is the almost same thing. This is gt square cos alpha. So this is the almost same thing as we have done in normal projectile motion, but only difference is that ax, earlier we have taken the x-axis to be horizontal, and so that ax was 0. Right? Now here the ax will be minus g sin alpha. Can you tell me how do I find the time of flight?
So taking the total
Y directions.
displacement being 0.
Y displacement to be
Displacement
0.
means 0.
So if I take y displacement to be 0, then I can write it is ut sin theta minus alpha minus half gt square cos alpha. So from this expression, what is the time of flight you are getting? Have you got this part? 2u sine theta minus alpha divided by g cos alpha.
So can you please explain why we took that displacement to be 0?
When the particle reaches from this point to this point,
Yes, sir.
right? Suppose A to B, what is the y direction displacement of the particle?
0.
0. That is why I have taken 0, because this is a complete time of flight, right? So in a complete time of flight, you will always find the y displacement to be 0, as the particle again lands along the same horizontal line or same x-axis actually. Can I find what is the range? How do I find the range?
U cos theta minus alpha into time of flight. Capital T. Time
No,
of flight, yes.
no.
Time of-
Look, here the x equation is not only ut cos alpha, but there is also minus half sin g sin alpha t square.
yes.
Yes or no? So in order to find the range, I will put this time capital T here in the expression of x. Can you understand?
Yes, sir.
So try to put the value of capital T in this expression and tell me what expression of range you are getting there. Look, how do I solve it? It is only a mathematical calculation. Again, you do not have to remember the expression, but I will derive it for you. So if time you have got 2u sine theta minus alpha divided by g cos alpha, then range expression you will find it is u cos theta minus alpha u into t. T instead of small t I will put capital T, so that is 2u sine theta minus alpha and divide by g cos alpha minus half g sine alpha into capital T square, so that is 4u square sine square theta minus alpha whole divided by g square into cos square alpha. We can simplify it in this way. You can see in the second term I can cancel out g. I can cancel 2 and 4, so 2 will remain there. So in both the terms 2u square by g cos square alpha I will take common, but in the first term there is no cos square, so I can divide and multiply cos alpha here. I can take sine theta minus alpha common from both of them. So inside bracket for the first term I will take cos alpha into cos theta minus alpha, and for the second term I will take minus sine alpha into sine theta
Can you explain
minus
what is the inside the bracket cos alpha?
yes,
Cos
cos
so
alpha
alpha then?
into cos theta minus alpha. You can see that this cos theta minus alpha I have taken common here, as I have
Yes, sir.
taken 1 by cos square and there is only 1 by cos, so I have taken 1 cos alpha also
Yes, sir.
inside this bracket. So now if you solve it, solve means if you just modify it, you will find this expression 2u square sine theta minus alpha by g cos square alpha, and there is one trigonometric identity which says cos a cos b minus sin a sin b is equal to what? Cos
Cos
of
alpha plus theta minus alpha.
cos a cos
theta.
b minus sin a
Cos
sin b
theta.
is cos a plus b only, and you can say it is alpha plus theta minus alpha is only cos theta. So that is the expression for range. Then I have a better way to calculate the time of flight and range, and in this way you will be able to solve these expressions very quickly, right, within few seconds. So let me first show you how we can find the same time of flight and range quickly. Okay. So suppose this was my inclined plane. This is my inclined plane, right? And I want to write an expression of displacement of the particle. What is the expression of the displacement of the particle that I can write? Do you remember the kinematics equation? Delta S equal to ut plus half a t square. Now, can anyone tell me whether I can use this expression in case of two-dimensional motion or not?
Yes, sir.
Yes, sir.
Yes. Why? Because there is a vector sign above all the vectors. Right? I have not used plus minus sign before them. Instead, I have actually used their vector signs. So I can use this expression for 2D, 3D as long as this acceleration is a constant. Okay. Now in your copy, just try to draw a vector triangle mentioning these vectors: ut vector, half a t square vector, and delta s vector. By the time the particle hits the inclined plane, this small t will be capital T and this delta s will be the range, right? So you can also modify this expression as r vector is equal to u capital T plus half a t square. Can you just try to plot these three vectors and draw a vector triangle? So as you can see that I can draw this ut vector along the u vector actually. Can you tell me in which direction I will plot this half a t square vector?
Vertically downward direction.
Vertically downward direction, because acceleration acts vertically downward. And in which direction this r vector will lie? The resultant of these two is definitely along the inclined plane. Can you understand this vector triangle? If not, then ask me.
Sir,
Yes.
sir, but ওই half a t square, স্যার এটা তো স্যার মাইনাস জি না, সেটা তো স্যার উল্টো দিকে হয়ে যাবে।
কি বুঝলাম না? মাইনাস জি বলেই তো
স্যার,
নিচের
এই-
দিকে করেছি।
হ্যাঁ তো স্যার, তো ওটা তো স্যার নিচের দিকে হচ্ছে। ও হ্যাঁ, বুঝতে পেরেছি। হ্যাঁ, ঠিক আছে।
So can you explain it why UT was along that direction?
Because u was along this direction.
Yes, sir.
U was along this direction, so ut vector will definitely lie along the same direction as u.
Okay, sir.
T is scalar.
Yes, because t is scalar. Half gt squared is the same thing, because g vector is acting downward, so half gt squared, the rest of the part is a number only. The vector direction will remain the same, and this is the r vector. Now if I try to understand what are the different angles of this triangle, let us first try to calculate them. Can you tell me what is this angle?
Alpha.
Theta minus alpha.
Theta
Theta
minus
minus
alpha. Okay. Can you tell me what is this part? This one? How much is this one?
Beta.
Yes, no, beta is not there. Only theta and alpha.
90 plus alpha.
90 plus alpha. Look, if I drop a perpendicular from there, then this is 90 degree and this is alpha, right? So this is the external angle of this triangle, so it is 90 plus alpha or not? Similarly, can you find this one?
90 minus theta.
It is 90 minus theta.
90 minus theta.
Now look, we have a triangle where all the side lengths are known and all the angles are known. Can you tell me?
rule.
Sine
Yes.
rule. Sine rule.
Sine rule,
We
sir.
will
Sine
use
rule.
a rule called
Sine-
sine rule. And can you write down the sine rule in your copy? Before I write it in this board, just try to write down the sine rule in your copy. Tell me, what should I write as ut divided by?
Sin 90 plus alpha.
Sin 90 plus alpha.
And what is sin 90 plus alpha?
Cos minus
Sir,
cos alpha.
The cos alpha.
Yes, it is plus cos alpha. Yes. That should be is equal to half gt square
Sin theta minus alpha.
Minus alpha.
divided by sine of theta minus alpha, and that is equal to range divided by
Cos theta.
Cos theta.
Cos theta.
Cos theta.
Cos
Right.
theta.
Sin 90 plus cos.
Now can you see that from this first two expression,
So that was 90 plus alpha, sir. So how
Nine-
it became cos alpha?
sine of 90 plus alpha, sine of 90 minus
Second
alpha, both are cos.
So same thing.
Yes,
No, not same. Second quadrant. In the second quadrant.
in second quadrant, but both are cos alpha, because in
The value
second
is
quadrant
same,
sine value is positive. Okay.
Positive.
So if I just try to solve the capital T from these first two expressions, what will be the value of capital T? Can you solve it for the first two expression?
U sin theta minus alpha by g half g.
No,
মানে
2 will
2
be,
u
So 2u
sin theta minus alpha by cos alpha g.
cos alpha g.
yes, by g cos alpha. So it is the time of flight that I have got from this one. Can you just relate this to expression and find the what is the value of r? Can you find what is the value of r? It is u cos theta by cos alpha. U cos theta by cos alpha into capital T. I will put the value of capital T here. So it is 2u sin theta minus alpha divided by g cos alpha. Come back to the expression of the range. R is equal to, you remember what is the expression of range? 2
U square by g. Acha. Sir, 2u square sin theta minus alpha cos theta by g cos alpha.
into cos theta by g cos square alpha.
By g cos alpha.
Cos square alpha.
Now I have to find the value of theta for which r is maximum. To find maximum r for a given u, means speed is constant, but what is the value of this angle theta? This entire angle I am talking about, this angle theta, such that the range along the inclined plane can be a maximum. So in order to find that, let us try to write down this value r in this way. R is equal to 2u square by g cos square alpha. Right. I will not write this 2 outside, but I will take this 2 inside. And we have this one, 2 sin theta minus alpha into cos theta. Why I am again modifying this expression? Because here you can see that in this particular expression, there are two places which holds theta, cos theta and sin theta minus alpha. So I can only maximize one term, but there are two terms simultaneously in this expression. So I'll try to simplify it. Do you know any trigonometric identity? 2
So
sin
2
A
sin
plus
A
B.
into sin A plus B.
Yes, sine of A plus B, 2 theta minus alpha plus sine of A minus B.
Yes, sir.
This one we will get. So it is actually u square by g cos square alpha into sine of 2 theta minus alpha minus sine alpha.
Minus sin alpha.
Now you can see that in this expression, only one place is there that holds theta. And it is very easy to simplify the value of theta to find the value of theta for which r is maximum. If I maximize this term, then I can say r is maximum. Yes or no?
Yes.
And what is the maximum value of this one?
1.
1. In that case, what will be the value of 2 theta minus alpha?
90 degrees.
90 degree.
So, okay, so this is the value of theta. From here, you can find the value of theta such that the range is maximum.
So 90 plus alpha by 2.
Yes. So, can I just modify it and write theta minus alpha is 90 minus theta? Yes or no? Tell me.
Yes, sir.
Now you can see that this is the vertical line that I have drawn, and this is the inclined plane that is given. And if you calculate what is this much angle, what you will get?
Theta minus alpha.
And what is this one?
90 minus theta.
So in order to maximize the range, these two angles should be what?
So equal.
Equal. But in order to maximize range, you have to project the particle in such a direction such that it will bisect the angle between what lines? Vertical line and the inclined plane.
Okay, sir.
Clear? Okay. Now you can also find an interesting fact regarding the last statement that I have made. When I project a particle from ground, is that statement also valid in this case? When I project this particle from ground, what is the angle between vertical plane and this vertical line and this plane?
90
And
degrees.
in which direction you have to actually project in order to maximize the
45 degree.
45 degree, right? So you can see this is a very general statement, right? In no book you will find this statement, but it will always happen in case of projectile motion.
That means we can find the maximum range when there is a bisector between the x-axis and the vertical line.
Vertical line, yes. Yes, you can say that. X-axis and vertical line. Here we have taken x-axis along the inclined plane. That is why I have written along the inclined plane and vertical line. This entire analysis is very important. Otherwise, questions are easy to solve in this inclined plane. Right? I will show you few examples also. But you need to understand this analysis. Now, if you have understood this part, just try to do the same thing. But in this case, I will project the particle from top of the inclined plane and it lands on the at the bottom of the inclined plane. As you can see in this diagram, can you find what is the range and time of flight? And just first calculate this part. What is range and time of flight in this case? Let us try to solve it. In which method I will solve it? Tell me. In conventional way or in vector?
Sine rule.
Sine rule.
Okay,
Sine
using
rule.
sine
Sine
rule.
rule.
Okay.
Vector triangle.
Using vector triangle, I am trying to solve it. Let us first draw the ut vector. Delta is equal to ut plus half at square. Ut vector will be along this u vector. Yes or no? Ut vector will be along this u vector given in your question. In which direction gt vector will lie? Direct vertical downward. It is a gt vector, and their resultant lies along the inclined plane, which is r vector. You will see this triangle, right, which I have drawn in red color. So this is the ut vector. This is the half gt square vector. Half gt square vector, and that is the range. First, tell me whether you could draw this vector triangle or not.
Yes, sir.
Yes, everyone should be able to draw this vector triangle. If you are confident enough in drawing vector triangle, then only you proceed in this method. Otherwise, conventional way is also there. But I always suggest my students that if you have studied vector, if you have studied so many times in solving vector question, then why not to draw this vector triangle and solve it easily. Alright, can you tell me what is the angle of this angle of this triangle?
Theta plus alpha.
Good, theta plus alpha. This one?
90 minus alpha. 90 minus theta plus alpha.
No, this part, this
This-
angle,
90 minus alpha.
90 minus alpha.
alpha.
90 minus alpha. Yes,
Oh,
90 minus alpha only. This is
minus
alpha.
correct, na?
So why not minus touched? Okay.
This angle is alpha, na? This angle is alpha.
Yeah, this is alpha.
Then this is perpendicular. So this must be 90 minus alpha. Okay. And what is this one? What is this angle? What is this top angle? 90 minus
9 theta.
minus theta. Good. Now I will use a sine rule where you will see that a range divided by cos theta. Yes, range divided by cos theta is equal to ut
So
divided.
how is it coming theta plus alpha?
This one. If this angle
Yes,
is
sir.
theta, if this angle is theta, can't I say this angle is alpha? If this angle is alpha, this angle
Acha,
will be alpha.
understood.
All right. So let us write down the sine rule first. R by sine of 90 minus theta is nothing but cos theta equal to ut divided by what should I divide?
The sine 90
90 minus
Cos
alpha.
alpha.
cos alpha.
Cos alpha,
Cos
yes.
alpha.
Sine 90 minus alpha is cos alpha, and that is equal to half gt square divided by what?
Sin theta plus
Alpha
alpha.
plus sin theta plus alpha.
Sine theta plus alpha. Sine theta plus alpha. So by equating this to 1, I will get what is the time of flight. You will get it is 2u sine theta minus alpha divided by g cos alpha.
So theta plus alpha.
Yes. I think you have got this one. No problem. And by using the same time here, we will find the range. By equating this to, I will find the range. So that is equal to u cos theta by cos alpha. U cos theta by cos alpha into time of flight is 2u sine theta plus alpha. Have you got these two expressions for time of flight and range? Everyone please check. Have you got these two expressions?
That should be g cos alpha.
Yes. That will be in denominator, that will be g cos
G cos
square.
square alpha.
G cos square alpha. Yes. I have done a mistake. G cos square alpha. Okay, now can you tell me what is the value of theta in this case to maximize r? What will be the value of theta in case I have to maximize r and u is fixed?
So 90 degree plus alpha by 2.
90 plus alpha by 2. Okay, I will check once. How we can solve that? You can also write it to be u square by g cos square alpha, and inside you will find it is 2 sine theta plus alpha into cos theta. Again, can I simplify this expression? 2 sine a cos b. How I can break it? U square
Sin
by g
plus
cos
b.
square alpha
Sin
sine
theta plus alpha minus theta.
sine
plus
a plus b is sine 2 theta plus alpha. Sine a plus b minus
Yes, sir.
sine a minus b.
Hmm.
Minus sine a minus b is sine alpha. The same expression I am getting. Okay, it will
So
be
minus
plus.
the plus.
The plus sin alpha, yes sir.
Plus sine alpha. So you can see that here also, in order to maximize this expression, what should be the value of 2 theta plus alpha?
90 degree.
90 degree. And interestingly, you will find the same thing.
Same, yes sir.
You will find the same thing if you just look onto this figure. Let us write down the same expression. 2 theta plus alpha was 90 degree. So can I write theta plus alpha is equal to 90 minus theta? Right. Now let us draw a vertical line from here and the inclined plane from here. Now can you calculate what is this angle?
theta plus alpha.
And what is this angle?
90 minus theta.
90 minus theta. Can you see that in order to find the maximum range, in which direction I have to throw the particle?
So along
Along the bisector of this
line.
of this vertical line and the inclined plane. So as I have
Yes, sir.
said that this always happens, and you should remember this concept. Alright, so these are the few things that we have studied here. I have written all these concepts here in this slide. I'll provide it to you. Alright, now try to solve this question. Okay, let's try to solve this one.
Sir, cot theta equal to 2 by root 3.
Yes, that will be the answer. Good. So let us assume that this velocity is u, although it is not mentioned in your question, and the particle moves in this path. Finally, it hits the inclined plane with a velocity that is perpendicular to the plane. Let us assume this velocity is v, and let us assume this to be my x-axis, this to be my y-axis. I will take all the components of the vector along this x and y axis. So initial along x-axis I will write my ux component is u cos theta, and along y-axis what is u component? uy is equal to u sin theta. Can you tell me what is ax and ay in this case? What is ax? If I take this is g vector,
G cos
Minus G by 2.
minus G cos 30
yes,
Minus G by 2.
along the
minus g by 2 is along x-axis, and minus g root 3 by 2 is along y-axis. Now if I ask you that the velocity is perpendicular to x-axis, then in which component, in which direction there is no velocity actually?
So please repeat.
If I say that the velocity is
X-axis, along
perpendicular
x-axis.
to x-axis, then which component of the velocity is actually 0?
So x component.
So if I take that x component of the velocity is 0, only y component of the velocity remains there, right? So if x component of the velocity is 0, here you can see that this is 30 degree, cos 30 degree, sin 30 degree. So if x component of the velocity is 0, then can I say that ux plus axt, that is equal to 0,
Yes, sir.
right? So in that case, what is the time after which its velocity is component along x-axis is 0? That I can find is by minus of ux by ax, yes or no? Can you understand this part? So if you put the value of ux by ax, minus minus will get cancel out. So can I say it is only 2u cos theta by g? First tell me whether this part is clear or not.
why
Yes.
final equal to 0 next.
Yes? Why x component is 0? Can anyone explain? Why x component of the velocity is 0 when it hits the plane?
So because cos 90
Clear.
equals to
The
0.
cos 90 will be
Because
0.
yes, because the velocity is along y-axis, so its x component is 0.
There
Now,
is no velocity along it.
yes, so vx equal to ux plus
190,
axt. That equation I have used, and I have just put the value of ux and ax. I have found the value of t. Now, can I say that this is also the time of flight, because the particle starts from here and it ends here, so it is also the time of flight,
Yes, sir.
and I can find the time
Sir?
of, yes, tell me.
So like when we find velocity along x axis, we also take like minus.
Minus g by 2.
Yes, sir.
That is why I have
Take
taken,
minus gt also, sir.
yes, minus gt, no, minus gt, minus g by 2 into t.
Okay, sir.
because I will have to take a component of acceleration g. Yes or no? This is ax, this is ay.
Yes, sir.
Alright. Now, if I say that in this time interval, what is the y displacement of the particle? Can you tell me?
0.
Yes, it is 0. Because it starts from here again comes back here. So what is the y displacement of the particle? It is 0. So if we use this equation, s equal to ut plus half at square, can I use in the same time the y displacement has become 0? So can I find that time is equal to, the time is equal to 2uy divided by ay. If you put the value of uy, it is u sine theta, and ay is minus, so minus minus will get cancelled out, g root 3 by 2. So can I say that these two times are same, this time and this time, they are same or not?
Yes, sir.
Yes. So if they are same, I will equate those. 2u cos theta by g is equal to 4u sin theta by g root 3. U and g will get cancelled out. 4 by 2 is 2. So what is tan theta is root 3 by 2. Can you solve this one? Let us first try to understand the particle is projected horizontally from inclined plane with 10 meter per second. Also range and time of flight. I can easily draw a vector triangle, as it is asking for range and time of flight. Then it will be easier to solve in vector triangle. So I will use the vector s equal to ut plus half at square. So ut vector will be along this line and half gt square vector will be directly downward. And this will be my range. If you do not agree, then ask me. I have only drawn a vector triangle like this. It is my ut vector. It is my half gt square vector. And this is my range vector. And very easily I can find out the angles. This is 30 degree. This is 60 degree. So can I write down the equation, sine rule, that 10 divided by sine 60 degree, which is root 3 by 2, is equal to half gt square, which is 5t square. So it is 10t, sorry. 10t divided by sine 60 degree equal to half gt square divided by sine 30 degree. Can I write down this expression? Is equal to range divided by sine 90 degree. Tell me whether I can write down this sine rule or not.
Yes, sir.
So from
Yes,
the
sir.
first two expressions, half of will get cancelled out. Time will be 2 by root 3. Time will be 2 by root 3 second. That is option B. And if I put the same time in the range, I will find it is 20 by root 3 into.
So since it's t square, won't it be root 2 by root?
No, tt gets cancelled out now. 1t will
Okay,
get
sir.
cancelled out. So range is 40 by 3, time of flight is 2 by root 3, and I have to find the speed with which it strikes the plane. How do I find the speed? Look, after time t, its velocity vector can be written as 10 I cap minus, if this is my x-axis, if this is my x-axis, right, and this is my y-axis, so it is 10 I cap minus gt j cap. Can I write this is my velocity vector after time t? Look, its x component remains the same, but y component initially it was 0, so only y component will be minus gt, right? So it is 10 I cap minus 20 by root 3 j cap. So what is the modulus of that velocity? Will be 10 root over of 1 plus 4 by 3 meter per second. That is nowhere 15 meter per second. So I think option B is the only correct option in this question. Check whether you have done it correct or wrong. Can you understand this entire calculation?
Yes.
স্যার 10 I cap minus GT cap GT J cap
Yes.
স্যার ওই পার্টটা স্যার GT পার্টটা
Vx plus Vy. Let us write it Vx plus Vy. Do you remember the formula for Vy?
হ্যাঁ
Uy plus
Uy
Ayt.
minus plus Ayt.
Now what is Uy here? 0. Its initial y direction velocity is 0 because it was projected along horizontal line.
ও হ্যাঁ
And acceleration is minus g and time t. So that is why I have written Vy is minus GTJ.
আচ্ছা
Alright. So I will end my class for today here only. And I will give you few questions to solve at home regarding the same concept that we have studied today. Okay, so you will be having few questions as your homework. This question you have to solve at home. This question again you try at home, and this question. Last two questions are a bit difficult one. This one and this one. You try to solve at home. If you cannot solve, then again we will solve it in class, no problem. But at least you try. You take a try. This one is also a good question. You take a try to solve it. This one, this is solved. This is solved. We have done this in our class, and this question is also your homework.